This lesson, we're going to talk about interest. The first interest formula that we wanted to go over is simple interest formula. Simple interest formula is amount equals to principal times 1 plus rate times t. So if we wanted to get total amount, this is the formula we can use. If we wanted to find out just interest itself, we can use this formula right here, which is interest is equals to principal time rate times time. Let's look at example 1. So this is asking you to find the future value of the bonds after 5 years. You're going to start the bond. Well, you obtain 5,000 bonds that pays 4.5% simple interest annually. After 5 years, they wanted to know what will be the future value is, right? So your future value is going to be A. So you're not only looking for interest, you're looking for total amount. So maybe we can use these formulas. We can't use this formula also. It's just that once you find the interest, you're going to add it into the principal. That's how you're going to find the amount. So there are two ways of doing it. Since we do have formula, let's see if we can use that formula. So we're trying to find A and principal starting 5,000. 1 plus your rate is 4.5%. So when you change that to decimal, it will be 0.045 times 5 because it's a 5 year, right? You need to do inside of the parenthesis and you do multiplication before addition. So when you multiply these two numbers, you get 0.225. When you add it to 1, you get 5,000 times 1 plus 0.225. So which is going to be 1.225 multiplied by 5,000. You will get 6,125. And that's going to be total amount. So that total amount is going to be interest plus the principal. So if you just wanted to find out the interest, you need to subtract the principal, which is going to be $1,125 will be just interest, and that it will be just interest, right? Let's look at example 2. It said Martha decided to invest $4,500 into saving account, earn 2.5% simple interest. How long will it take her investment to double in value? So with the formula given, this time they're not asking for total amounts. This time they're asking to find how long it's going to take. So because we have a formula, A equals to principal time 1 plus RT, if we can fill everything but times, right? That will be unknown. Then we should be able to solve for that. So we know that principal is going to be 4,500, right? So this is the principal. This is the interest rate. And we need to change that to decimal, so it will be 0.025. And then T is what we're trying to look for. It means we need to know what A is equals to, and it's a double in a value. So how much you get when you double 4,500? You should be able to multiply to find your double amount, and that will be your A. In order to solve this equation with one unknown variable t, right? That's one unknown. That's what we're trying to solve for. First, we can get rid of this multiplication so that we can open the parenthesis. What I will do, I will divide both sides by 4,500. So that gives you 1, and this is going to be 2. Because the multiplication is out, you should be able to open the parenthesis. Now we can get rid of positive 1 by subtracting 1. That gives you 1 equals 2.025t. This is multiplication, so in order to get rid of multiplication, you divide both sides by the same value. That's another 1. So t is equals to 1 divided by 0.025. And when you plug in that into the calculator, you will get about 40. So what this means, it will take 40 years to double your amounts with 2.5% interest. Let's look at one more with the simple interest. So the problem will need to say that are going to use simple interest in order to use these two formula that we got introduced in these sections. And this is how much you wanted to invest it, starting investing. That's going to be your principal. And 3% is going to be the rate. And 19 years is going to be T. And A is asking how much interest will she earn. So how much interest she's going to get, right? So just finding an interest so we can plug into I equals PRT, which is principal time rate times time. When you multiply all that into the calculator, you should end up getting around 9,120. So this is just the interest itself. And then B is asking how much is in the account at the end of the 19-year period. So this is asking for find what is the total amount, right? So that's asking for A amount. If we already have interest, in order to find total amounts, you're going to do interest plus principal, which is 9,120 plus the principal started with 16,000. When you add them up, that's going to be your total amount, which is going to be 25,120. So that's total amount, that's interest. If we use different formula to find our total amount, you should end up getting the same solutions, right? If you use A equals to P times 1 plus RT. The next example we're going to look at it is the same types of interest, but this time is not simple. This time is a compound. So we're going to see what's the difference when you have a simple interest versus compound interest. So when it's a simple interest, the interest is going to be earned every year, right? When it's a compound, they will give you a different compound period. So how often the interest is going to be accumulated, right? So for example, the first example is say compound quarterly. Your compounding period is going to be 4 because compounding quarterly means you have 4 times a year, right? And when you're looking at your formula right here, we know A is for total amount, P is for principal, R rate, N is the one that is compounding period. So N is going to become 4 when it's a compound quarterly. If you have compound monthly, it's going to be 12. Compound semi-annually, it's going to be 2. So with that in mind, we have this problem with P and R given and N and also T is given. And they want you to find out the amount, right? So if we replace all this number, 3,000 times 1 plus 0.03 over 4 to 4 times 10 exponent. So when you're doing calculating, you need to start from inside out, right? So when we do this, you do 0.03 divided by 4 on the calculator first, and whatever the number you get, you're going to add 1, right? So you will find out 0.03 divided by 4 will be 0.0075, and then you're going to add 1, which is going to be 1.0075, and use the 40 exponents. So if you have a calculator where you cannot put all this at once, then that's how you will need to start it, from inside out. So you will do 1.0075, use the exponent notations to the 40 as exponents, and then push the equal sign and then multiply by 3,000. And most of the calculator, your exponent sign is either x to the y exponents, right? Or y to the x exponents. Depends on what calculator you have. This is all the exponent sign, right? That's another one. I seen newly you have x to the box. That's another exponent sign. So when you do that, you will end up getting $4,045.05. So that will be the total amounts you're going to get with all this given informations. Again, if you're using your calculator and you're not getting the same number, maybe come and visit my office hours, because everyone have different types of calculator. I will not be able to go over it in class. Okay, so then let's look at the second one from this section, compound interest. So this problem, they explain what's CD and what's bonds and all that information, but actual problems start from here, right? It says, suppose you deposit $3,000 in CD, paying 6%. So this is the principal, this is interest, pound monthly. Compound monthly means N equals to 12. How much will you have in accounts after 20 years, right? That's going to be T equals to 20 years. So again, they're looking for total amount. So when we replace it into the formula, principal times 1 plus interest, 6% become 0.06 over N, which is compound monthly, to and T exponent, right? So it will be 12 times 20 exponents. So you do the same thing. If it's not the graphing calculator, you need to start from inside out. So you're going to do 0.06 divided by 12 and then plus 1. So when you do 0.06 divided by 2, you get 0.05 plus 1. So it will be 1.005. And 12 times 20, you get 240 exponents. So you do 1.005 to the 140 exponents times 3,000 on your calculator, you should be getting 9,930.61 as the total amount. What about example 3? Like I mentioned before, looking at the word problems, always understanding about 60 to 70% is important. So maybe you can stop this video and read the problem and see how much information you can get out from. And then if you don't have 100%, right? If you didn't understand 100%, you can still start writing down what you know. So here, they're talking about your account is grow all the way to 40,000 over 18 years. And she believed it was 60% compound semi-annually, which is twice a year. So that's going to be n equals to 2. And how much Lily need to invest it in the account now, right? So in order to make 40,000 after 18 years with a rate of 6% compound semi-annually, how much she need to start it? So basically this is asking what will be the principal, right? So let's put it into the formula, trying to make 40,000. And principal is what we're trying to figure it out. And 1 plus 6% is 0.06 over and 2 times 18 years. And it means you're going to simplify parentheses with exponents. So whatever the number you end up getting there, you're going to divide both sides by it so you can isolate P. So when you do 0.06 divided by 2, that's going to be 0.03. When you're adding 1, it'll be 0.3. 2 times 18, 36 exponents. So basically, you're going to divide both sides of equation by 1.03 to the 36 exponents. So you can isolate P by itself. Your principal is going to be 40,000 divided by that, right? And you will end up getting about 13,801.30. So if you end up investing this amount for how long? 18 years, semi-annually with 6% interest, you will end up getting 40,000. That's actually really good amount, doing nothing, right? But don't forget it's 6%. Okay, let's look at one more. So what about this time? What are we asking? So it said, how much will Lily need to invest it, right? So that's going to be a principal again. Oh, this is the same types of problems. Only thing different, compound daily. So n is going to become 365. So let's see, what will be the difference? We're going to replace all the value that we know. And this is going to be same as when you simplify this, you end up getting 1.0001644 to the 6,570 exponents. So you're going to divide both sides by the same thing. so that this will make it 1. So you need to divide the other side by same thing. You will get your principal, $13,583.56. So if you start with this amount, after an 18 year, you're going to make it 40,000. If you wanted to compare the one example before, if it was compounding semi-annually, so this is the only thing different, semi-annually, right? When n is equals to 2, your principal have to be 13,801. Compounding daily, your principal have to be 13,583. So this is going to be less. So the smaller amount, but compounding period get bigger, you get more money, right? So that's something that we can compare from example 3 versus example 4.